Okay, there's all 9 of them. If you guys are still having trouble with that, make sure and ask tomorrow. Or for B-Day people on Friday, just keep some questions on the side and ask, and I can go over anything you guys want. But these are all findable from knowing where you are in the unit circle, finding your coordinates, and using fractions. That sounds terrible. That's a lot of math that people don't like doing, but that's what you got to do. Okay, I'm going to sketch the graph of each parent function for secant, cosecant, and cotangent. You guys have done these before. Now the reason I'm doing these is because we are about to talk about the inverse cosecant and the inverse secant and the inverse cotangent. So I want you to get used to the graphs a little bit, okay? So if you remember secant of x, one more time, that is 1 over cosine. So anywhere cosine is 0, we're going to have an asymptote. Okay, so I'm just making a little graph here. I should put this on here for you. Sorry about that. Where is cosine 0? Up here at the top it's 0, and down here at the bottom it's 0. That's pi over 2 and negative pi over 2. So I'm going to go to the pi over 2's, and I'm going to put asymptotes. I'm going to go to this pi over 2 and this one, and I'm going to put asymptotes. And the secant function ended up being up here and then down here. One way you can tell where these parabolas go is you could graph the cosine function. It starts up here, and it goes down here, and it goes up here, so you just follow it along and make your parabolas. The cosecant function, go 2 notches, put pi, go 2 notches, put 2 pi, go 2 notches, put negative pi, go 2 notches, put negative 2 pi. Here we go. Cosecant is 1 over the sine of x. So anywhere that sine is 0, we have asymptotes. Sine is 0 here at 0 degrees, and over here at 180 degrees, or pi. So the asymptotes are at the 0s and the pi's. Another thing that you guys should really start getting used to, so not that I want these memorized from you guys, but I think you should be able to go, okay, secant, that's 1 over cosine. Cosine is 0 is at the half pi's. I could start putting asymptotes real quick. Cosecant is 1 over sine. Sine is 0 at 0 and pi, so these asymptotes are all at the pi's. The cosecant function is 1 over sine, so sine starts here, it ends here, it goes up, it goes down, right? It goes like that. So we're going to have a parabola up here, parabola down there. I'm going a little faster because we've done this before, right? We've done this several times. You guys should definitely be okay with how this is going. And then the cotangent function, cotangent. Well, let's go put the pi and the 2 pi. So we know what our graph paper looks like here. I'm being a little sloppy with the pen. Sorry about that. So this is going to be cosine of x over sine of x, right? Tangent, sine over cosine. Cotangent is cosine over sine. So anywhere that sine is 0, we have asymptotes. So it's just like this one. The asymptotes are at the 0s and the pi's. So I need to reference these graphs on the next page. What I'm not going to do for you guys today is I'm not going to talk about inverses being x's and y's getting switched and try and graph the inverse and then decide the restricted domains. We're just going to take a look at these and figure out the restricted domains as a result of our last conversation. Okay, so there's your parent functions. Now imagine them switching. Obviously, if it when switched, let me just turn the paper a little bit for you, okay? If it switched, this would fail the vertical line test, right? If this was the y-axis and this was the x-axis. So we're going to find some limitations for the domain so that the inverse can be a function. And so I'm getting right after it right here. Finding values for the inverse, cosecant, secant, and cotangent. Here are all 6 restricted domains. These are the ones you've already done. Sine was negative pi over 2 up to pi over 2. I'm going to continue to say negative 90 to 90 because visually we're better at that one, right? Cosine, 0 to pi, those are included. These are the ones we've gotten over the last few days. Tangent is not included. It's negative pi over 2 to pi over 2. But I put parentheses because at the pi over 2's, we actually have asymptotes, so the graph can't actually equal those. Now for secant, secant is 1 over cosine. And so when I graph secant, I graph the cosine function. It's not going to be negative pi over 2 to pi over 2 because look, that if I turn that sideways, that would fail the vertical line test. So just like cosine, it's going to be 0 to pi because look, 0 to pi, if I turn these sideways, 0 to pi would actually pass the vertical line test. So secant, just like cosine, is going to be 0 to pi. Okay? Cosecant is 1 over the sine of x, and for the exact same reason, it's going to be the exact same as the sine, negative pi over 2 to pi over 2. And then cotangent, I would like to say it's the same as tangent, except for one reason. Look at the asymptotes here. It's at 0 and it's at pi, so when I switch this sideways, when I go to pick one of these, it starts at 0 and it goes to pi. So unlike tangent, cotangent's actually going to go parentheses, but it's going to go 0 to pi because it has a different denominator, so the asymptotes are in a different place. Those are your 6 restricted domains, so whenever I ask you an inverse trig function, you got to respect those in your answer. See what I mean? So here we go. The inverse secant of 2. That's got to have you thinking, I have no idea, so I hate math. Well, let's think about it for a second. It's 1 over the cosine. It's 1 over cosine. So if you flip that, we're really looking at where is, let me write it this way, where is cosine 1/2? Isn't that the question we're asking? Flip the 2 and get 1/2. We're looking for where is cosine 1/2. Now, secant and cosine, this top one and this one, secant and cosine. Cosine is from 0 to pi, and secant is from 0 to pi. So I'm looking for an angle from 0 to pi in quadrant 1 and 2, where cosine is positive 1/2. Well, we have positives for x over here, but we have negatives for x over here. So this has got to be in the first quadrant. And which one has 1/2 as an x value? It's right there. The answer is pi over 3. Okay, the cosecant of 1. You got to love having 1 there, because when I flip that and do the reciprocal, it's 1 anyway. This is 1 over the sine of x, right? That's what this is. So this is really the inverse sine of 1. That's that 1 flipped, right? Okay, and what angle has a sine of 1? Well, that one's way up here, where the 1 is the y value. That's pi over 2. The cotangent of negative square root of 3. The cotangent of negative square root of 3. Okay, well, cotangent isn't just going to be one of these flips. The cotangent is the cosine of x over the sine of x, right? So we're going to have to unsimplify this. Right now, it's like it's over 1. So that means like the cosine is square root of 3 and the sine is 1. That doesn't make sense to us. This has to have been simplified from this. I'm looking at the inverse cotangent of the square root of 3 over 2 over 1/2. Now, I know that's weird to you guys. I'm unsimplifying a fraction. But if you look at the unit circle, every single denominator in our unit circle is a 2. So it's pretty easy to say, okay, if I'm going to unsimplify this and find a denominator, let's go with the 2 because it'll make sense for us. So now look, I'm looking where the x value is negative square root of 3 over 2, and the y value is 1/2. Well, look at cotangent. Okay, cotangent, inverse cotangent is from 0 to pi, unlike tangent. So I got to go from 0 to pi, and I got to find a place where x over y is negative. Well, positive over positive is not negative. It's going to be over here. This is the second quadrant angle I'm looking for. Okay, and my point is negative square root of 3 over 2 and 1/2 in the second quadrant. That's right here. That's going to be 5 pi over 6. You see, this isn't like put a number in an equation stuff here. You got to do some problem solving here, right? You got to do some thinking, and that's why I keep telling you guys, your knowledge of the unit circle will help so much. If you guys are getting better at knowing which angles are where and what coordinates are there, this stuff goes quicker for sure. Okay, secant, once again, is 1 over cosine. So I'm looking at the inverse cosine of, instead of 1/2, it's going to be 2. That never happens. The biggest cosine value I get is 1. It doesn't go to 2. That's not possible. In fact, if you think about it, cosine from SOHCAHTOA is adjacent over hypotenuse. There's no way, if the hypotenuse is the biggest side in a right triangle, that adjacent over hypotenuse could be bigger than 1. This is undefined. Trick problem, people. Let me go back to this. Where's the secant 1/2? Let's look at the secant function. That's 1. That's negative 1. There's 1/2. The secant is never 1/2. That was a trick question. See what I mean? That was a trick question. It's just mean. It's just mean. Hey, let's go to the next page. Okay, let's use the inverse trig functions to find angles that aren't on the unit circle. Okay, approximate each value, which is going to be an angle, in degrees, and then approximate each value in radians. So I'm going to get you started here, and then I'm going to stop and let you guys do a bunch of work. I'm talking about using the calculator here. When I say approximate, instead of finding the exact value, I mean hit buttons on your calculator. Okay, let me do a first couple of them for you. If it's in degrees, I want to be in degree mode. So hit mode and make sure that you're in degree. Most of us are right now, I think, from the last conversation we had. Inverse sine of 2/5. Look how easy this is. Second sine 2/5. Before I hit enter, I want you to think about this. Inverse sine is from negative 90 to 90, and it's positive. Isn't this a first quadrant angle? Right? And it's 2/5 is like 40%, right? It's 4/10. It's not quite 1/2. So the sine of 30 is 1/2, and this is less than that. So you can kind of start guessing what this is. It's going to be an angle, should be a little less than 30. 23.6. 23.6 degrees. You guys, I'm comfortable with you just pushing buttons in the calculator and getting the answer, but I think you should be able to think your way through this. Look, the inverse cosine of negative 0.3, inverse cosine is 0 to 180. This answer is definitely going to be, I'm going to go here, inverse cosine, negative 0.3. That's definitely going to be between 0 and 180. Where's cosine negative? Not the first quadrant. It's negative in the second quadrant. So this is going to be in between 90 and 180. 107.5. Let's round all of them to one decimal. Okay. I'm going to leave those for you guys. We'll get to secant. How am I going to figure out the secant? There's no secant button on here. Well, I know that this is 1 over cosine, right? So that's how I'm going to put it in here. 1 divided by the inverse cosine. Oh, there's a better way to do that. I was thinking of just trying to find the secant of x. I think what we could do, scratch that. Can't we just do inverse cosine of 4, right? So this is going to be the inverse cosine of 4. I'll just flip that instead of flipping the whole thing. Now, if you're smart, cosine's not going to be 4. We just learned that trick a minute ago. So I'm going to hit second in cosine. I'm going to hit 4. I'm going to be told that we have an error. This is undefined. Why is it undefined? Let me go back to the secant function. Once again, I'm looking for a secant value of 1/4. It doesn't go there. It's higher than 1 or less than negative 1. Almost got fooled. Now, cosecant, it does actually go bigger than 1.3. So this is the same as 1 over the cosine of x, cosecant. So this is where I think I can go 1 divided by, it's cosecant is 1 over the sine. Sorry guys, I'm going too fast for myself. That says sine. Live with it. 1 divided by the inverse sine of negative 1.3. Okay, I don't like that. Oh, I did it wrong. Hang on. I'm going to use the same trick. Watch this. Inverse sine of, we'll just flip this like we flipped that. 1 over negative 1.3. That's what we need to do. My bad. My bad. I'm rushing. Second sine of 1 divided by negative 1.3. There we go. And it's negative 50.3 degrees. Okay? Should make sense because cosecant and sine have to be from negative 90 up to 90. Negative 90 up to 90. And if it's going to be negative, it's got to be in the fourth quadrant, and that one is. Okay, so for every one of these, I just want you to do, like this one's cosine, do the inverse cosine of 1 over 25. See what I mean? For this one, let's use the fact that this is 1 over tangent. So for this one, we're going to put the inverse tangent of 1 over negative 0.9. Put that in your calculator. Okay, and then also, I want you to go down here and change over to radians. So you would hit the mode button and just change over to radians, and you're going to do the same thing. The inverse sine of 2/5. Now look, the answer is going to look weird because it's not going to give you anything with pi. It's going to give you a decimal. Okay, 0.41. And we'll talk about what those decimals mean in a minute. So go ahead and do the rest of them with your calculator, and I'll ponder all of my mistakes and sit here in shame.